Hello everyone. I'm here to redo problem 2.23. I didn't put in enough information last time and it seemed like I was solving it for the first time, which I almost was. So here it is again. Here's the question. When jumping, a flea accelerates at 1500 meters per second squared, but over 0.57 millimeters. How high does it jump? Well, we have our knowns. The acceleration is 1500 meters per second squared. The distance is 0.57 millimeters, or it's easier for me to put it in meters, so 0.0057 meters. And here's the drawing. We're trying to find the height, the maximum height that it jumps, and there's T0. Actually, I'll use a pointer. There we go. T of 0, there's the distance and the acceleration with increasing lengths and arrows, and then there's the flea. Now the kinematics that we're going to be using today are this first one, change in velocity, and also the solving when we don't have time, and we're solving for y. And these are, don't know this yet, didn't solve for that one. Well, at this point in the video, I hadn't solved it yet, but we have our knowns. Acceleration's 1500 meters per second squared. The distance is 0.0057 meters. Time isn't necessary, and the initial velocity would be 0. So first we'll use the change in velocity. We plug in the numbers, 2 times 1500 times 0.0057 meters. That gives us 17.1, but we still have to square root it because final velocity is squared. And then we get final velocity is 4.13521 meters per second. Now let's solve for y now that we have final velocity. So we have this equation, which I just rearranged. This is solving for time, but I rearranged it to solve for y. So f minus final velocity minus initial velocity all over 2 times acceleration equals y. Alright, now we plug in our final minus initial, which just equals 4.13521 meters, divided by 2 times g, which is 9.80, and that gives us 0.872449 meters. Now, when I plugged that into Mastering Physics, it didn't want that, it wanted it in centimeters. So here it is, all of that times 100, because centi means 100, and you have 8.7 centimeters as the answer for the height. That's the max height that the flea jumps. And I assess that this makes sense because a flea would jump to a height of 8.7 centimeters, although it is not very high considerably, but it's high for a miniature bug like this flea. Anyways, thank you for listening, and I hope this kind of shows more of my process, specifically how I got this equation. I know my last video didn't really explain how I got that, but this time I showed all my work, so there we go.